Good morning again. This is session number 2 in our wastewater tutorials with operators without borders, presented by our tutor, Mr. Mike Gosselin. And I will go straight over to Mike. I think he wants to make it more interactive and would like you, if you have questions, you can raise your hand, and you can also, I guess we would like to see faces. So when you're going to speak, you can always put on your camera and unmute your mic. You can also put your questions in the chat. Is that okay, Mike?
Yeah, that sounds great. Thank you.
All right.
Yeah, good morning, everyone. Following the last session, I noticed that I had a few questions, which was great. So hopefully we'll have a few more as we go along. Also, at the beginning of each session, I'm going to have several slides with some review questions. And what I'd like, hopefully everybody's got their keyboard handy on their computer. I don't need an answer from everybody. I'm not going to track each off, but I would definitely like to see answers from a few people as we go through. There'll probably be 20 or 30 questions based on the previous session's material. So just to make sure we're getting some of that information captured. I wouldn't say that these questions are specific to examinations, but they're very similar or in the same ballpark of some of the things you might see when you write the exam. All right, so having said that, we're going to get going. I'm going to share my screen. And I will do my best to monitor the chat as we move along. Bear with me for a second. There we go. So one of the questions that popped up last time was important criteria for facility design, and I gave this some thought because it's not something that's easily answered. There's a lot of components to that, and I whittled it down to maybe 4 or 5 things that I find really important. We're in the process of planning for a new digestion facility, and some of these criteria that I'm going to mention directly affect that facility. So I wanted to mention those, and we'll go through them quickly. So facility location is huge. Nobody wants, whether it's a digestion facility or a wastewater plant, if you ask them, they're not going to want it in their backyard. So having a facility location that is acceptable can be challenging. Also a location where your wastewater can flow as much as it can by gravity, which saves lift stations, which are a huge cost, a lot of maintenance time, all that kind of thing. One thing that really needs to be considered is the type of wastewater to be treated, whether it's strictly domestic or whether you have some industrial waste mixed in there. That will drive the type of treatment that's going to be considered. Also, your discharge stream, whether it's going into a lake or a river or an ocean, and depending on your requirements for effluent discharge, that discharge stream can really guide the level of treatment that you have. In Kelowna, we discharge to a very large lake, which has about a 70-year turnover time. Thus, all the wastewater treatment plants are biological nutrient removal facilities to reduce any nutrients or reduce nutrients as much as possible going into that lake. And the type of process to be considered, you definitely want, in my mind, something that's reasonable at a minimum to achieve the goals that you need for your discharge stream, potentially even a little more advanced as restrictions or regulations change and maybe the requirements for the discharge of the process. Better to have a little more advanced treatment than just something that just meets the requirements. And lastly, support. Whether it's a facility that's brand new, whether it's being retrofitted, technology that's easily accessible, where spare parts can be purchased readily, engineering support to fire up the facility or get it started, or even as you process troubleshoot as you go along. Mechanical support, definitely a key factor. If you can't get the parts to replace a piece of equipment, then that piece of equipment doesn't do you much good. And lastly, operational support. Key factor running in facility is the operation staff. Some operation staff are mechanical as well as operations. A lot of larger facilities, operators are strictly operators. So your day-to-day job, you're a key factor to making that facility run as effectively as possible. The effluent discharge quality relies solely on your shoulders. At the end of the day, if the facility's not performing as expected, then people are going to be looking at operations staff going, are you operating this effectively? Are you not? So people need to be educated, trained in wastewater operations. They need to be supported from mechanical, electrical, and engineering groups, and everybody needs to work as a team. So I'm hoping that those points answered the question somewhat. I'm just going to I'm trying to see my notes here at the same time. See if there's any questions. I'm going to stop the share for a minute, just for a second, and see if there's any questions.
No, you have no questions in the chat so far.
Okay, thanks. All right. So we're going to move on to a little bit of review from the last session. Like you said, I've got several questions. Hopefully, people will use their keyboards, type in their answers. Again, I'm not expecting to see an answer from everyone, but at least several to make sure everybody's on the same page. Okay, we're going to touch on safety first. So who's responsible for your safety? There we go. Now I can bring up the chat section here. I'm just having a little issue trying to get my chat up at the same time here. Bear with me 2 seconds, sorry. I can't see the chat as I'm sharing my screen, so I'm going to pause there for a minute, just assume that some people are answering. But at the end of the day, you may have the training, you may have the knowledge to do something safely, which is awesome. But you're responsible for your own safety. So if you don't know how to do something, or if you're unsure, you need to ask, you need to do your research, you need to request the training that needs to be provided. What is a JHSC? So that's a joint health and safety committee. And joint health and safety committees are made up of staff, which are a key component, usually a safety representative from the safety department, and also management. It's important to have all three components there to look at problems and address them effectively. So as a worker, what safety rights do you have? So as a worker, you've got the right to know about hazards and the right to refuse unsafe work. At the end of the day, you know, everybody needs to be safe. They need to go home to their families, and you are responsible for your safety. And if you don't know how to, the right to refuse unsafe work sounds like an incredibly threatening term, and it's not meant to be. It's simply meant to be, if you don't know what's going on or you're not sure what to do, you need to ask. So you're basically saying, okay, let's put the brakes on here for a minute, take a look. I need some training, I need some knowledge, or I have to go find that information. And what does the term WHMIS stand for? So it's a workplace hazardous material information system. Hopefully you did. There will be questions on WHMIS on your exam. So in the last part, in the PowerPoints that you took a look at, make sure you take some time and review those for sure. What are the three components of WHMIS? There's labeling, which are on the containers, education, which are the WHMIS documents provided to you, which contain everything from personal protective equipment to first aid treatment to the makeup of the chemical, exposure limits. Everything should be on that sheet, and the material safety data sheet as well. I kind of touched on this just on this past question, but what does MSDS stand for? That's a material safety data sheet. There should be a standard location for all your MSDS sheets, easily accessible by all staff. There's no way that anyone's expected to remember all the information on an MSDS sheet for 50 products that you might have on your site. So if they're all in one location, easily accessible, whether that's online or a binder, whatever the case may be, they can be easily reviewed and staff can take a look at what's needed. Those need to be reviewed or updated on an annual basis. See, work safe requirement for that. Okay, so if it's a paper copy, they actually have to be a new one printed out. Even if it hasn't changed, it has to be a new one printed off annually and replace the other one. So what are the routes of entry into your body for chemicals? We've got inhalation, absorption, and ingestion. So inhalation is quite easy, you know, what you're breathing in. Absorption, what might be on your skin and absorbed through your skin. And ingestion, obviously, what you would swallow. What is acute chemical exposure? Short period of high exposure or short period of exposure at high concentrations. So if you were in a manhole and something came down the line, your gas detector went off, and by the time you got out of that hole, you could have some kind of acute exposure. Again, these sessions are being recorded, so I would highly advise you to go back and take a look at these and just refresh yourself as we move along. And what is chronic exposure? So that's the extended period of exposure at a low concentration. Many areas of this facility, especially basements, maybe dewatering centrifuge activities, might have low levels of H2S or other items kicking around in there, and they would be chronic exposure because you're working in those areas all the time and potentially a low exposure. So combustible liquids have a flash point between 37.8 C and 93.3 C. And flammable liquids have a flash point below 100 Celsius. Now for level 1 and 2 exams, you do cover definitely some safety questions. So this one will something similar to this one will be on there as well for sure. Why is it important for you to understand the classification of fire extinguishers? It's basically to use the right extinguisher for the right job. You know, if you had a Class A extinguisher, which is a water extinguisher, you would not use that on a Class C fire or an electrical fire. Many extinguishers now are classified as ABC, which are perfect because that's the best one to grab, or the easiest one, because it pretty much covers the gamut of what you need. So if I was going to grab an extinguisher, I wouldn't look for the specific type. I'd look for an ABC, which is a chemical which can be used for all three of those types of fires. So what's the definition of a confined space?
You may use your mics, because I believe Mike may not be able to read his chat room, so use the mics to answer if you can. You can just put up your hand and then.
Okay, and my chat's finally working now too, so thank you for that. Some good answers. Okay, I'm just reading over chat. Okay. There was a question about job safety analysis in the chat. I would not necessarily think that you're going to see much of that on the exam. Okay. Good. I'm glad I got the chat working now. So what's the definition of confined space? Let's see if we can get a couple of answers there. Remember, when you're writing these exams, they're not looking for a long-winded question either. So there's a good one, limited entry. Yeah, that's definitely part of it for sure. So it's limited access and egress, partially enclosed space, and not designed for continuous occupancy. So when dealing with confined space, what is meant by a competent person? Hopefully everybody's got their keyboards handy and can type in a couple answers. That's right. Qualified because of training and experience. What gases cannot be detected by smell? That's correct. H2S with low concentration. Carbon monoxide, carbon dioxide. Yeah, that's right. carbon monoxide, carbon dioxide, and hydrogen sulfide at low concentrations. Great answers there. Thank you. I'm going to switch out of safety and touch on a few questions from applied sciences. What are protozoa mainly feed on? That's correct, bacteria. And what is the impact of high nutrient loads on creeks and streams? Eutrophication. That's right, consumes oxygen, which kill fish. Eutrophication, they're all correct answers. So can you explain the compound makeup of H2O and H2S? Just waiting for an answer or two.
Hello. Good morning.
Morning.
Can you hear me? Okay.
Yeah, I can. Yeah.
So would it be like it has 2 hydrogens, 1 oxygen for H2O, and then 2 hydrogens and 1 sulfur, I think it is? Is that what you're talking about for the structure?
Exactly.
Okay. Thank
Yeah.
you.
So H2O is compound makeup, 2 atoms hydrogen, 1 oxygen, and then H2S, 2 atoms hydrogen, one atom of sulfide. Thank you. What are photosynthetic bacteria? You said you can either type in the answer or just use your mic, whichever is easiest for you.
Bacteria that depends on the sun.
That's correct. They make their own food from sunlight. No, misspelled there, sorry, but they make their own food from sunlight. And why is testing for E. coli important? Another way to look at it is what if you find E. coli, what's happening? So E. coli are an indicator organisms. One of the first signs that your treatment objectives are not being achieved.
Yeah, in the chat, it's Nicole says indicator organism for feces.
Yeah. And what does the word protozoa mean? Well, I misclicked there, so I gave you that answer right away, but protozoa means little animal. Okay. Explain organics and inorganics.
Organics are compounds with carbon and inorganics are without carbon.
Correct. You bet. Thank you. I had another question. How often should a plant test for E. coli? That depends on your regulations, your effluent requirements. We're set to test on a weekly basis. We test more than that just so we can monitor, but it'll all be based on whatever your effluent requirement testing is required. Is a pH of 5 acidic or basic?
acidic.
Correct. So if it's acidic, you're going to get corrosion. Also detrimental to your bacteria. If low pH situation exists for a long period of time, bacteria in your bioreactors or mixed liquor tanks or RBCs or anywhere your bacteria are, your microorganisms are going to suffer. And can you explain basically what alkalinity is? So alkalinity is the ability of water to resist pH changes. And that's one that I think I've seen on several of the exams for sure. We talked about this earlier about eutrophication, so I don't think we need to touch on that. Everybody got that right. Definitely part of eutrophication are effluents with higher nitrogen and phosphorus. They are going to, nitrogen and phosphorus are going to stimulate growth of algae and other components in receiving streams, and they're going to choke off everything else. Excuse me. What is a BOD test?
BOD stands for biological oxygen demand, and it's the amount of oxygen within those, not solution, but what you have that it takes up, like the oxygen intake rate, something like that.
Yeah, that's right. That's really good. It's a 5-day test, so that's important to remember. And it measures the amount of oxygen consumed in that sample. So when you do a BOD test, what's the incubator set at? What temperature? And you're going to see this question for sure. (20°C). So make sure you commit that one to memory. And the last question, some of the review. So why do we disinfect wastewater effluent?
To kill the residual bacteria that are resistant to biological process.
You bet. Great answer. Thank you. Yeah, it's inactivate or destroy pathogens. Yeah, I'm going to stop sharing my screen. Any questions from the review? Okay, don't see any questions, so we'll move on to the next PowerPoint. So we're going to talk about motors and drives for a little bit. Now, I'm just going to share my screen. And I fully realize that we're covering a lot of information remotely. So if there's any, make sure you do ask questions as we go along. So motors and drives. Now, operators are not expected to be electricians by any means, but they need to have a firm understanding of what's happening with motors and drives and the electrical service going to those units to protect the equipment and protect yourself. You don't have to commit this graphic to memory, but keep it handy. It's nice to review this, or if you're trying to figure out some information. It's pretty straightforward. So you have P, which equal in these equations equal watts, I is amps, R is ohms, and E is volts. So if you were given a question, you had were provided the volts and the amps, and somebody asked you what the watts were. If you didn't remember, you look back at this sheet, and so it's okay. Volts times amps equals watts, and that's exactly how this graphic works. So to break that down a little bit, you know, volt is, you can think of that, it's the pressure force of an electrical current. So what's being pushed down that electrical line? There's a lot of common voltages which are listed there. The ones they don't list that we use in Canada are a lot of 480 volt and 600 volt at most of our facilities. Are you aware of what the voltage is coming into or being used at your facilities? So amperage is the unit for measuring the rate of flow. So it's kind of like the water flowing through a pipe. Like that's as the electrical service moves along, the amperage is the flow of through those lines. Okay. And ohms are used a unit measuring for resistance. It's kind of like if you're familiar with pipes and head loss in a pipe as you're pumping down a long period of line. It takes more and more energy to move that water down the line. That's because of the head loss and the friction in that pipe, and that's exactly what ohms are measuring in as far as electrical units. And watts are the total power of an electrical circuit. Just reading the chat there. Yeah, a lot of 400, 600, 292 kVA. Okay, thanks. Again, this isn't something that you have to commit to memory, but it's definitely nice to have around the Ohm's law triangle. Now you may have this will be provided to you as part of a formula sheet on your exam, and so definitely when you see questions, and there's one on the next slide, refer back to the tools that are provided to you. So if you have formula sheets and stuff, then take a minute and look for the correct formula and enter it in. I can't stress enough, if you were given a question such as this one, and if you didn't know exactly during the exam, you're given a question such as this one. If you didn't know exactly what's being asked or how to find that answer, move on to questions that are familiar to you. Save these types of questions till the end and come back. I don't know how we used to mark exams. I have no idea how many exams that you used to come across that had the last 10 questions were blank. People ran out of time. They didn't have time to answer. So that's 10 questions that could possibly put you into a really high mark, or even enough to get you over the minimum mark. Right. So what's referring to the triangle that was just shown to you. So what's the voltage if you measure resistance in ohms, 22 ohms of a current of 10 amps? So if you go backwards, you just put the numbers into this triangle and do the calculations. So it's E over I, and R. So you don't know the volts, right? So it's asking you what the volts are. And you look, sorry, you don't know volts, but you know the I and the R. And so to get the E, it's I multiplied by R. Amps times ohms will give you 220 volts. So there's two kinds of electrical circuits. And again, we're not trying to make electricians out of anyone, but you definitely need to have some kind of understanding. So there's direct current and alternating current. The first one we're going to talk about, alternating currents. It's commonly used everywhere. AC alternating current, or AC alternates in directions, and it moves at 60 times per second. So what's kind of special about electrical AC is the voltage can be readily changed, thus making it more suitable for long distance transmission lines. So you can easily put more down that line with an alternating current. You may have transformers at the other end to step it down, depending on your facility. If you're a 600, 480 volt facility, your incoming power is much higher than that, and then it's transformed down to 480 or 600, for example, and to run your equipment. This is kind of what alternating current looks like, how it moves. I'm just going to play that again if I can. You notice that the light bulb shines at the peak and the valley. Okay. Direct currents or DC. Now these ones, unlike alternating current where the current moves back and forth, direct current is only one direction. So it moves from a negative to a positive charge. Okay. Common uses of DC currents are your car. You got a car battery that's all DC. So it moves from negative to positive. Oop, there we go. So that's the path. That would be the same whether it be your car or DC drive. Any apparatus would move like that, whether it has a battery, or a lot of times it'll be alternating current that's provided, and then it needs to be changed into DC. Single phase, mainly used for like small motors and lighting systems. Single phase wiring could be supplied to like your pump house and run your chlorinator, your pumps, your lighting, any of that type of things. It's important to note that there's 240 volts between the red and the black wires, and then 120 volts between each, the red and the white wire and the black and the white wire. A lot of people in Canada have hot tubs, especially when it's colder out. It's nice to sit in a hot tub. And those hot tubs are 240. So they use 120 power and change the wiring around a bit and use the red and black wire together to provide 240. So those same wires can provide 120 or 240. So that's what single phase looks like as it's moving, alternating current. Good representation of the way to look at it. Three-phase circuits, talk about those next. You use for large voltage items. You know, motors, larger motors, anything over 5 horsepower typically uses a three-phase. Three-phase motors are usually less expensive. They operate well. Three-phase systems have 4 wires, 3 of which are live and 1 is neutral that goes to ground. So typically the wires are red, black, blue, and white. And that's kind of what three-phase power looks like. You'll notice that it's staggered a little bit, so you can push, excuse me, push way more down the voltage down the line. Any questions on power before we move on? On your sites or facilities you work at, do you have electricians on site that would handle most of the power issues, or do you have to contract those out? We've found that having our own electrical staff or mechanical staff on site is very beneficial. They have taken an ownership just like the operations staff do, and that way it's they do a really good job. They understand what they're working on. They actually help guide and train some of the operations staff as well, able to pass on information to them. So that's good to see that you have some electricians on site. That's very interesting. I'm not sure where that writing came from, but I'm going to get rid of it here, I think. So give me a second. I'm going to stop the share. So we're going to talk a little bit about motors, common types of motors, three-phase AC motors. You see most of those around, wound motors and synchronous AC motors. Excuse me. So the three-phase induction motors, I would estimate that the majority of your equipment has something similar to this. Whether this motor, for example, is more like something a larger size that comes from a blower or a large pump. But I would assume that you have a lot of those in place. Rotary motors, they're used on somewhat, but not as much as a squirrel cage motor for sure. And last, the synchronous motors, large applications, power generation, other types, extremely large pumping stations might use a large synchronous motor. Some of the common drives, we're going to switch to drives that you might have in your plant. So you have belt drives, chains, variable speed, direct couple, flexible shafts, right angle drives. We're just going to touch on a couple of these. So belt drives, pretty straightforward. Pulleys are mounted on the pump shafts, and then the belt drives in between them. We have a lot of dissolved air flotation units that use belt drive, and they work really well for adjustable speeds. Ours are hand controlled, just a dial to adjust the speeds up and down. Chain drives, the note here says it's used in slow, medium, and high speed applications, which is true. Most of the places you're going to find these are slow and medium, whether it's chain drive on a pump, chain drive on a primary clarifier. Chains come in plastic, metal, in different formats depending on their application. And some other commonly used drive, variable speed drives or VFDs. I'm quite sure a lot of your pumps have VFD drives. Direct coupled connections. So those are physically connected together to drive the unit. Flexible shafts. Equipment that's a little bit of distance apart, so it has it needs to be a little flexible to withstand any torque changes, that kind of thing. And then right angle drives, where vertically mounted equipment is driven by they call it a horizontal mounted driver, but basically the motor is up top, and then at 90 degrees, the pump's down below. What are some of the would you say that most of your motors in place are the three-phase AC motors? And do you have a lot of VFDs that you might use as well? Just waiting for a couple answers on those. Okay. So with some of your drives and other mechanical equipment, operators are definitely required to understand them, do some minor maintenance in larger facilities. Some of the smaller and mid-sized facilities, operations are much heavier involved in maintenance, and if there's not on-site mechanical staff or even sometimes limited budgets, their operators are required to do a lot of this mechanical maintenance. That's why when you write your certification exam, it's broad-based over whether you're working in a small facility, a large facility. There's not a separate exam, it's one exam for everything. So people really need to understand all of these components that we're covering so far, so they can do well on those exams, because again, they're not written specifically for one facility or another. I know that in many large facilities, some of the stuff that we've covered today and last Thursday, a lot of operators wouldn't see any of that, but it will be on their exams, and they're expected to have some kind of understanding. So I'm going to touch a little bit on this next section on HVAC. So heating, ventilation, and air conditioning. I'm going to pick and choose some of the slides that we're going to talk about, only because there's a lot of information here and well worth the read. But definitely, we're operators. We're not HVAC technicians. So bear with me. Get the next. I'll get the next slide show. Now, having said that, HVAC technician is not a bad job to be in either. They're probably getting paid about $40 an hour in our area to be an HVAC tech. All right. So in HVAC, heating, ventilation, and air conditioning. So basically there to provide comfort for people, whether you need to be cooled in the summer or warmed in the winter. You'll see a lot of these outside air conditioners in many different locations. And then similar to many houses, there's two separate units. One will be for air conditioning, one will be for heating, but they use the same ductwork. So it just depends on the season or the temperature control. Basic refrigeration cycle. You have a compressor that feeds a condenser, goes through an expansion valve and then an evaporator, and then back to the compressor again. So it's a closed loop. some of the basic HVAC equipment, you know, fans and blowers, which need to move the air, the furnace or heating unit, filters. Many times the filters are an operator's job to change. So you'd look on your manufacturer's specs for that, see, make sure the frequency that's required, change those. Filters do take some time to go around your facility and change, but they can change the longevity of your equipment by many, many years. Having clean filters is a must. This is a really good graphic just to understand how some systems may work. It's an interesting read, but it's not necessarily needed. We're going to talk about just 4 of these systems. We're going to touch on the packaged rooftop unit, the split system, the heat pump, and geothermal. So many of your locations, I'm quite sure you have these type of packaged rooftop units. We just talked about condensers and compressors and filters and stuff, and they're usually all contained in that one unit. It's delivered on site, put in place, hooked up, and it's ready to go. Split systems we touched on already, but basically you're saying you have an air conditioning unit and a heating unit, usually tied together so they don't run at the same time via the temperature control. So you select heating or cooling off the temperature control, and it would tell which unit to run, and using the same ductwork, of course. So heat pumps, not sure if you have any experience or exposure to heat pumps. They work very well. They're not as fast acting as a separate heating and cooling loop, but they can do both. A heat pump can heat and cool. It just depends on which way you're moving the inside. And lastly, we're just going to touch on geothermal systems. So basically using the you're circulating water through pipes in the ground and using the heat from that to heat a building. Okay. There's a lot of other slides on HVAC that I'm not going to touch on this morning, but definitely give them a read. It's more, I would say they'd be more of interest for you than a requirement. Okay. Just going to switch PowerPoints. And in case you're wondering, don't worry, there'll be many slides coming up about actual treatment things. So we just need to get through some of these first points. I will say again that a lot of the stuff we covered will be on the exam, and they're relatively easy marks to achieve. So we'll take another 5 minutes or so, and then we're going to take a quick bio break. But let's start talking about cathodic protection. Bear with me. Just got to share the screen. I say that all the time just so you know that I'm doing something in the background. Do you deal with any cathodic protection, or are you aware of cathodic protection in any of your facilities or pipelines? So one answer to cathodic protection is no. Anybody else have anything to do with cathodic protection or any dealings with it at all? So cathodic protection, it's designed to protect your piping. All right, so corrosion is caused by a reaction between metallic pipe and its surroundings. So basically the pipes in the ground, what's in the ground causes the pipe to rust. Now, with cathodic protection, you wouldn't be able to necessarily eliminate all of that corrosion, but you can definitely reduce it by a substantial factor. We have an effluent line that travels from our facility to the lake. It's been in there for, excuse me, it's been in there since 70s, 80s, sometime that was installed. And, you know, knock on wood, we've had no issues with it whatsoever. But that line is cathodic protected all the way through. Any tie-ins to that line are actually separated, excuse me, with physically with a gasket or something else to prevent any corrosion of that pipe. Adversely, you could, some of those main lines that are, if you put in AC concrete or pipe, it might be a better application as well. So just a little history. It was like 1820s as Sir Humphrey Davy was working with the Royal Navy and started to attach small quantities of iron and zinc to the hulls of their ship. And that was through his tests. That's where he found out that when the ships were sitting in salt water, he was able to extend their life. So with cathodic protection, a direct current is impressed into the pipe by means of a sacrificial anode or by a rectifier. Basically, what you're doing with an anode system is giving the corrosion a different direction to flow. So the anode system is installed in the ground, usually 5 feet or so away from on the line. It's connected with a cable physically to your line. And what's in the container, the anode, will degrade over time. And when it degrades enough, it's replaced. But what it's doing is drawing all the electrical current in the ground. So it doesn't rust the pipe, it's going to rust the anode, or at least reduce the rust on the pipes. Okay. So zinc and magnesium are used a lot. They'll rust a lot easier than a steel pipe will. There's a really good picture below the ground. You got your steel pipe, you got your line connected, you know, you're minimum 5 feet away. And this is a packaged anode system in the ground. You got an impressed current system. So impressed current system uses a rectifier to convert alternating current to direct current. So basically, it's the same thing, but you're using direct current. You have a rectifier that's pushing DC down this line, and it's changing the connectivity of the pipe. So it's forcing the soil and what's in the soil to be drawn towards the anode. If you have higher power over here, lesser power over there, it's going to draw the corrosion this way. You got an anode in a conducting bed, which is deteriorating over time. So with these systems, you have to monitor the rectifiers. It should be done on, we suggest every 6 months or so, but we do it on a monthly basis. You want to make sure that the documents are on site, that the previous readings are available to people when they go out there, because what they do is you go out there, see what the last readings were, see what they are now. So that's the only way you can tell if you're getting the protection on your pipe. So if your rectifier if your readings are starting to drop off, it means your anode is potentially being reduced its capacity to absorb. So you need to crank up the rectifier, which basically supplies more DC power down the pipe, down the line to the pipe to force everything towards the anode. So they suggest every 6 months, but we do ours every 60 days. We take a look at it. Also annually, we have a tester come out and test our whole line. Our discharge line is all steel out into the lake, and it's about 65 meters or so. So you need deep sea diving with hyperbaric chambers to access it. So it definitely is something that's not easy to look at. So we spend a lot of time making sure that it's protected properly. Okay, just looking for questions. All right, so it's about 5 after 9 your time. So why don't we take a 5? It's been about an hour. Why don't we take a 5-minute bio break, and then we're going to get back and we're going to talk about some cross connections, and then move on to some source characteristics. Any questions so far? Again, I know there's a lot of information to try and take on online, but I definitely appreciate the questions. I definitely appreciate the answers that we've had to the review questions this morning. I'd like to throw it out to group quickly before you go. Did you find that review, those questions helpful? Did it help nudge the memory a little bit, maybe give you some things to think about? And again, it's focused, those type of things are designed to potentially highlight things that you might want to go back and review. If you don't know the answer, there's nothing wrong with that. It's just, okay, well, maybe I need to spend a little more time taking a look at that kind of thing. All right, thanks, Nicole. Appreciate that answer. Okay, so like I said, about a 5-minute break or so. We'll come back at, I'm just trying to do, yeah, you're 3 hours ahead. So 9:10 your time?
Yeah, 5-minute break.
Okay.
Okay.
Everybody get up and stretch. Thank you.
Yeah, stretch, bio break, get your coffee.
Yes. Thank you.
Okay. All right.
Hope everybody had a chance to refill their coffee this morning. Coffee is definitely a good thing. Just get the PowerPoint going. So we just finished talking about cathodic protection. We're going to spend a few minutes talking about cross connections. Just for interest, we probably have 1 or 2 sections. Hopefully we'll get through most of them today. That are outlier modules. Sorry, just bear with me a second. And then after these are done, then it'll be focused on the treatment component of the program for the next several weeks. It's important to get through these questions because the operators need to understand these. They need to know what to do. They need to know who to call and that type of thing. So bear with me. Okay, here we go. So cross connections. These are actual or potential connections between non-potable and potable water supplies. They can perform a serious health hazard if you're drawing contaminated water into a water system, and it's easy to do. As soon as you have contact between potable and non-potable water, and the potable water system, maybe the pump goes down or there's a drop in pressure, it will draw contaminants back into that water system. Once contaminants are in the water system, you are directly affecting the public health. So this is, any plant, there's always repairs going on, or out in larger systems, there's new pipes going in the ground. they describe this as a dynamic problem because everything there is in flux all the time. We're always fixing things. We're always connecting things. And the only way to deal with cross connections is through knowledge and diligence. And that's knowledge of staff as well as people that are brought in to do the work. Just highlighting this photo, this seems like a simple thing. Maybe somebody has chemicals or something in that tank in the back of the truck, so they've got the garden hoses connected there. Looks like they have something to support the garden hose so it doesn't kink off and it's filling the tank. If there was a reduction in the potable water supply, it would draw that chemical directly from that tank and back siphon it right into the system, right into that person's house. And so this is why we're talking about cross connections today. Education is essential for sure. Cross connection backflow is a certification program here for testers. I'm not sure if they have the same program in your areas. And recertification is done on every 2 years. Many facilities, using best practices, have a cross connection control program. It's your best option. For us, the cross connection control program, anytime there's a new pipe going in the ground, work being done on site, and that requires lines connected or repaired or new lines installed, that cross connection person's involved in the loop of communications. They don't necessarily run out and inspect every line that's installed, but they have an overview and can help sometimes provide information that's needed. So cross connections, mainly back siphonage and backflow. So back siphonage is just like that picture we saw with the truck in the chemical tank. If the potable water pressure dropped off, it's going to back siphon right out of that tank and into the system. And backflow is higher pressure on one side, overcoming another pressure. So you have a potable water system that's certain PSI or KPA, and whatever it's connected to on the other side has a higher PSI or KPA, and will push that contaminant directly into the potable water supply. This is it's just it's going to be a few slides just as an example of how easy it is to provide cross connections, which can dramatically impact people, mainly done by people that, they inadvertently, they're not sure what they're doing, so they're just connecting things up and think they're doing the best job. This is a fish cleaning station that's at a lake. So people come, they catch the fish in the lake and they come here and they clean it. There's obviously some instructions on what to do. But if you look underneath, it's this cluster of pipes that's connected, and obviously there's a certain space requirements here that were a struggle. But everything's connected together. It's might be a little hard to tell from these pipes, but they're all connected on both sides and providing a cross connection right into that pipe. So that's the drain from the sink that's connected to the drain here, which is connected right to the potable water supply. Many times, connections are made simply a matter of convenience. Like, oh, I'm working on something. Oh, there's a pipe right there. I could just connect to that quickly, get the water I needed. And you're trying to do your job, and you may not be thinking, or somebody else may not be thinking about the dangerous situation that they're actually causing. So plumbing installers must know about hydraulic and pollution factors. They need to be aware of cross connections when if you call a plumber in, they're connecting the lines. If they're not made aware, they would do exactly what I just said. They connect to the closest water line potentially causing a cross connection. So backflow, it's the reverse flow due to pressure. Excuse me. So backflow and back sipage connection or prevention. Certain types of backflow valves are out, backflow preventers. You'll see in this one, like these are actually check valves, so it will not allow flow to move in this direction. It's only going to allow in one direction, and it's actually flowing in this direction. If the water pressure started to try and push from this side and move back, it would drop the plate in here and not allow any flow back into the potable water supply. Do you deal with any of the backflow equipment or connections on your site? We have a couple main connections to our main potable water supply from the city. Goes through a double check valve assembly that's checked annually, and I've had people, some of the operations staff and mechanical staff certified so they can test these. They have to be tested annually to ensure that they are functioning as they're supposed to. We'll talk a little bit about backflow preventers because these will be on your exams for sure. You know, air gaps, barometric loops, vacuum breakers, double checks, valve assemblies, and reduced pressure devices. So an air gap, this is the most common one for sure. If you're filling maybe a chemical tank, maybe you have a polymer system or something else feeding some dewatering equipment, the easiest way to get around any cross connection is to have that air gap. So that water actually would drop into that tank. And even if the tank filled up and started overflowing, it would not bridge this gap. So you have an air gap there. You don't see too many of the loops that I've dealt with due to the fact that you need 35 feet in height. So what it's saying is it's not going to back siphon through this pipe. It won't you would basically will not overcome the 35 feet distance there. Pressure vacuum breakers, you know, they consist of a check device or a check valve and an air inlet. So they work off air pressure. Basically, when the pressure builds up in that system and it overcomes air pressure, it pops a valve, which then gives you a break in the suction, preventing backflow. And just to finish off, so cross connections, you know, they happen every day and people get sick or they get ill. Education understanding is the only way to prevent some of that. Any questions on cross connection or backflow devices? Do you have any chemical makeup systems in your plants? And if you do they have any backflow or cross connection prevention? Just curious. I'll ask that question while I'm bringing up the next slideshow. Anybody with cross connection experience or dealing with it in your plants? Okay. All right, so one of the last more outlier modules we're going to cover before we get into some of the more treatment is regulations and compliance. This course was mainly developed in Canada around Ontario, so some of the things might be specifically written for Ontario requirements, but they will be, something similar is going to be used in your area. So here we have Ministry of Environment, which oversees wastewater treatment systems, collection and actual treatment facilities. And their main goal is to provide safe drinking water, protect public health, protect the environment. All operators operating any systems are required to be licensed. They use the word licensing, but it's also the same as certification. In our Ministry of Environment operational certificate, which is a certificate that allows us to operate our plant, it specifically lays out that we are required to have an operations staff that are certified and that their certification is up to date. Part of that certification is facility classification. So classification for facilities runs from levels 1 to 4, and so do operator certifications 1 through 4. Our facility classification for a level 4 facility, it requires you to at least have a level 3 operator. Okay, working towards the same level as the plant, and then everyone else in the plant can be certified at other levels. Typically, level 2 operators are usually used a lot in treatment facilities. There is an exception to this process where you can use a professional engineer or a series of engineers, but this is not. It's a temporary basis. It's meant to, mainly if you're starting up a new facility, if you need to get it going, you're hiring staff, maybe you're training staff. So you use engineers working in conjunction with staff to get, so you can fire the facility and at least meet your ministry requirements. So we have operators in training. Basically, that's the first step into an operator career. Classifications or licenses for operators levels 1 through 4. Levels 1 and 2 typically require, well, all of them require grade 12 education. And then to get through class 1 and 2 or levels 1 and 2, it's education experience. So one year for a level 1 and 3 years for a level 2. Levels 3 and 4 require a bit more education, and they also and a little bit more experience time. The education equates to about 90 CEUs, which is equates to about a 2-year college program on top of your grade 12 or any other information. In Ontario, a person that holds a class 1, 2, 3, or 4 wastewater treatment license is deemed to also hold a class 1 wastewater collection license. Many areas it's not the same, they're different. They will not cross over. Some of the time may be applicable from one certification to another, but it does not necessarily mean that you're certified in collection just because you have a treatment ticket. License renewal, in Ontario, it's every 3 years. In BC, it's every 2 years. ABC, I think, has said every 2 years for their professional operators. And I'm not sure where your local area, what they are. But to renew, you need to be a member of the program. You got to pay your annual fees, of course. And most areas now require continuing education requirements or CEUs met every 2 years. Or 3 years. CEUs are like courses like this. Any online courses are applicable. Any in-house training is applicable. You might find, excuse me, if you have suppliers coming in to provide you training as well, if they apply to the certification board, there's a good chance that their training might be acceptable through CEUs. The certification documents and licenses need to be displayed at the facility. Okay. And the exam applications. So that's part of what most of you indicated to me last during our first session. Everybody's here prepping for a level 1 exam. Judging from a lot of the answers I got after the first review this morning, it doesn't look like it'll be a challenge, but definitely take your time when you go through, sit that exam, make sure you really understand the questions as you're working through there. You will hear the term overall responsible operator, or ORO. That's the operator that's leading the charge for the operations group, holds correct level of license or certification for that facility. At the end of the day, that ORO, or responsible operator, the level 4 or level 3 operator, is the one that's going to have everything land on their shoulders as far as the operation of the facility, potentially even the certification and staff. They may not be in charge of making sure people get training or write their exams, but they would be expected to be tracking that and ensure that operators are meeting their requirements. All right. And we talked a little bit about the duties of the operator in charge. There you go. So the operator in charge, you know, they got to set the operational parameters, operate the facility safely, make sure this, the measurements, the sampling, the treating, the monitoring are all being done, ensure that records are maintained, ensure the equipment is monitored. And again, they're not expected to do everything themselves. They're expected to be in charge and ensure that these things are being done. There is a brief slide on strikes and lockouts. If you're a unionized environment, this may be of interest. If you're not a unionized environment, then it doesn't apply to you. But during a strike or lockout, typically operations staff are considered essential services. So they are, minimal staff are required to be at the site operating the facility at all times. All right, so that's the last non-treatment type section that I wanted to discuss, and I'm glad we got through those because I said they're important. They will be on your exams. Any questions on any of that so far? Everybody still with me? A little bit of music there. So we got thumbs up. Everybody's still here. Good. Face-to-face training is always much more interactive, and that's totally understandable why we can't do it at this time with COVID and stuff. But all right. So we're going to talk now about get into more of the treatment stuff. So sources and characteristics, and bear with me while I bring up the slideshow. All right. So why do we treat wastewater? Basically, it comes down to protection of public health and protect the environment. Those are, you can talk about a lot of other components, but that's effectively what it is. In this module, we're going to review some of the substances, part of the makeup of wastewater and why we need to treat those. So I'm quite sure everybody is fairly familiar with the terms sludge and scum. Large amounts of solid settling to the bottom would be sludge. Things floating at the top would be scum. You need to not only deal with those in the plant, but you definitely do not want those going to your receiving stream. You could have rafts of scum floating down the lake or the river, and definitely not something you want to do. Oxygen depletion, we talked about eutrophication already. Of interest, most fish can thrive if there's at least 5 milligrams per liter and other of oxygen and other factors that are in their favor. So pathogens in wastewater cause disease. Most treatment facilities not only reduce nutrients to some sort, they reduce solids, and they have an impact on pathogens. If your facility isn't treating pathogens through the process, it will at the end with some kind of disinfection. Some of the known diseases or examples of diseases: typhoid, cholera, polio, dysentery, and hepatitis. Most operation staff are required to get hepatitis shots, as well as some boosters for other known diseases. Sorry. So some wastes definitely affect the clarity and color of the receiving streams, making them unsightly for or unpopular for recreation. So we're going to talk a little bit about the chemical, physical characteristics and quantities that are in wastewater and what can be expected. So there's 5 major sources of slideshow froze. There we go. 5 major sources of wastewater. So domestic, which comes from residential use. Commercial, which would be restaurants, that type of thing. Institutional, maybe from prisons or jails. Industrial, which are more processing plants or laundry facilities, that type of thing. And infiltration. Infiltration is huge, or can be huge, and very tough to deal with. So a very tight system being monitored addressing infiltration is critical. So domestic system or wastewater originates from homes, and that's everything from laundry facility, kitchen sinks, bathtubs. It's all considered as domestic waste. Of note, we make very good use of education programs for the public about what not to put down the toilet, what not to try and cram down the sewer system, because everything winds up either in a lift station or at the plant. So commercial wastewater is similar to domestic, waste from laundry mats, car washes, that type of thing. For your systems, I'm curious, just asking the question here, how are you mainly domestic, or are they combined systems? Just wait for a couple answers here. So the type of systems or the wastewater you have coming into your plants are domestic or combined or industrial treatment facilities? Combination. Okay. We've got 2 treatment facilities in Kelowna. One of them is that handles commercial, some industrial and residential. And then we have another facility. It's just basically a pre-treatment for a fruit processing plant. Very high loading coming from that plant. And if we didn't have a pre-treatment facility, basically it would overwhelm our main plant and kill everything at that plant. So, all right, some sources of further sources in institutional wastewater, hospital, schools, penitentiaries, that type of thing. Industrial wastewater, very, it can be very complex, especially some of the jails. They put a lot of things down those sewer systems that are hard to deal with, and anything that can fit in there, like you'll see bottles and cans, and we've pulled out full bed sheets out of lift stations, all in one piece. I have no idea how they got them down there, but they definitely went down the sewer system. Infiltration, so basically water leaking in the system through, this would be a pipe joint that's having some leakage. Also, there's a lot of infiltration that's caused in our areas, people, just due to their lack of understanding. But we have a lot of rainy times throughout the year. So some people think it's a really good idea to tie the downspouts of their house into their sewer system. That way they don't have water running everywhere all over their yard, which kind of makes sense. But if you don't know the impact you're having, now you've increased the flow from residential areas tenfold by all the rainwater. Every time it rains, it was going directly into the sewer system. A good way to test for that is with, for those types of infiltration, is smoke testing. You put a canister of smoke in the sewer system, and it migrates. As you can see, this line's not full, so it would migrate in the spaces and work its way up. And basically, you see the smoke rising from the people's roofs and houses, and it tells you that they're tied in improperly. And our main goal is to educate people. So if that happens, we don't run out with bylaw and try and find them. It's more of an education. It's like, hey, you need to disconnect this and do it properly, and then we'll be back to check on it. Infiltration in this picture with the lines are definitely a little harder to see. You have to send a camera down the line, some sort of CCTV program to find these out where they are, and that type of thing. So what would be, if you had infiltration like this, what would be your first indication that this is happening? So if you had this amount of water infiltrating your line, how are you going to know this? What's going to be the first indication?
Oh, high flows coming into the plant.
You bet. Either into a lift station or the plant, you bet that the flows would be higher. Plant. Awesome. Great. Perfect. Three basic types of collection systems: storm, separate, and combined. I'm not sure what type of system you have in your areas, but we're going to touch on all three of these. So a storm system, it's basically that. It's rainwater. It's collected, and hopefully it does not go to your plant. It maybe can be directed right to a stream or some kind of waterway. Separate collection system basically separates, so all you have is sewage in that line coming to the plant. Much easier to treat. You do not have, every time there's a rain event, you do not have the problems of increased flows of the plant. What we're finding right now is we've done a lot of painstaking work to reduce water consumption, which is fantastic for the water guys, but didn't turn out so well for the wastewater. Your systems are designed to work on a certain amount of flow and load. Flow going through the system, so things aren't settling out in the system. When it gets to the treatment facility, it's expecting to see a certain combination of flow and load. And what we're finding is our loading is steadily and dramatically increasing, and our flows are dropping off. So we're winding up using potable water more to flush the lines, keep everything moving in the plant, keep it fresh so it doesn't go septic. And then we're having to adjust how we have our plant set up to perform treatment. We're also looking at, excuse me, we're also looking at potential different forms of treatment to deal with this higher loading and less flow. And then the last one is the combined system, so which is basically storm and domestic systems tied together. Some areas this works fine. If you have areas with a lot of rain, this could be very detrimental to your plant. There's wet weather conditions. A lot of plants will actually bypass a certain percentage of flow. And what they say, or what they're trying to accomplish there, is once you've achieved X amount of flow, it's mostly made up of rainwater now. So we're just going to bypass the plant and pump it directly to receiving stream. Those are typically found in ocean type communities, or ones that are on the ocean, because they do get a lot of rainfall. So we're going to talk about physical and chemical characteristics of sewage as it relates to wastewater treatment. Just checking our time here. We're doing good. So the physical characteristics: temperature, turbidity, color, odor, and solids content. There will be questions on your exam about physical characteristics for sure.
You have
So,
just to interrupt you,
yep.
somebody has their hand raised. K on King.
Oh,
Go ahead.
Yeah, about that bypass system. So when you bypass the plant, you said they make an assumption that it's mostly rainwater, so they'll bypass stream. But are there requirements to test the stream for increased contaminant?
the facility that I worked at in Metro Vancouver, which is on the ocean city in BC, there was no requirements to test that, to test those bypasses. When it got to a certain, like I said, it got to a certain flow, we actually pumped it directly out into the ocean with no requirement for testing. Now, do I personally agree with that? No. You should at least take a grab sample and test that out for sure. But that's a really, really excellent question. Your operational certificate or Ministry of Environment or Health would provide the recommendations for that. That was a really good question, though. Thank you. Wastewater temperature. So temperature is usually a few degrees warmer than potable water. Most of it's been heated in a house somewhere, or baths and showers, before it's discharged to the system. So we're looking at anywhere from approximately 10, 20, 25 degrees Celsius. Of note, in the winter, our winter operations will drop down to anywhere from 8 to 10 degrees Celsius. In the summer, we're hovering around 18 to 20. Our facilities are much easier to operate at higher temperatures. And if you think about it, it kind of makes sense. If your bacteria and organisms are living, breathing things, it's like if you go outside in the summertime when it's nice and warm out, you got a t-shirt and shorts on, you're running around and doing things and you're very active, the organisms are exactly the same way. When you get to the lower temperatures, people are putting their parkas on, they're not going out as much, they're staying inside, they're not as active, and the biological component of your plant, it does the same thing. Everything slows down in a temperature or in a lower temperature. the way you're going to combat those lower temperatures, if not sure, I'm assuming you all live in very nice warm areas, so you may not have to deal with this. But what we do is we have to increase our mixed liquor suspended solids, increase our bug mass in the winter time. So we have a larger bug mass to do the same amount of work. And larger, I mean anywhere from 1,000 to 1,500 milligrams per liter. And we'll talk more about those solids contents later on in this series. But we're basically just a little bit shy of doubling our bug mass to perform the same treatment in winter as we do in the summer. So turbidity, the term turbidity is used probably a lot more in water than it is in wastewater. You know, the turbidity units are how water systems measure the quality of their treatment, that kind of thing. But it is used in the water industry in general. So it's basically anything that has some turbidity is, you know, the appearance of being a little cloudy or murky, okay? Or murky, I should say. It's caused by very finely this divided solid matter in the wastewater. So the color of domestic wastewater is usually slightly, just slightly gray, partly decomposed. If you have wastewater that's black, smells like hydrogen sulfide, then it's sitting in your influent sewage that's black or it smells like hydrogen sulfide. Somewhere along the line, it's sitting in the system too long. It's starting to go septic in those lines. If you have a lot of that coming into your plant, it will dramatically affect your bug mass. They can't deal with that. They will, your performance of your plant will degrade over time. And then fresh domestic water has a musty odor. I do know that that term is used in some of the examinations as well. It's usually not unpleasant, but you can definitely tell something's there. Septic wastewater has like a rotten egg or a sulfurous compound. It should be easily detectable. All right. So solids components. We're going to talk a lot about solids, inorganics and organic solids as we move along. Typically, at the influent of your plant, you have bar screens, for example, that will remove a lot of solids so they can't affect the pumps and the other equipment going downstream. And then hopefully you have some kind of grit collection system as displayed on the picture here that collects your grit, potentially cleans it before it's discharged to a bin and sent off. Do your facilities have bar screens or some type of screening in advance? Or some of the older facilities may have grinders at the head of their plant. I'm just curious whether you deal with grinders or screens.
We have a lot of automated machines that remove the incoming matter.
Okay.
Such as grit and fine particles and any larger particles. We have a machine specific.
Nice. Okay, good. You know, bar screens are definitely some type of screening facility in advance is definitely the way to go. Grinding used to be the standard treatment type of method, but all you're doing is you cut things into small pieces, send them into your plant, and then there's some magic that happens in a plant, and I don't know how it happens, but the rag balls, they seem to form together, and I'm quite sure everybody's seen these, especially in a digester, for example. So better off, if you have to do something with it, better off to screen it, remove it, and get it out of there. So Wastewater composed of organics and inorganics. So we talked about that. Organics contain carbon, inorganics no carbon. Organics are basically anything living, and inorganics are like sand and gravel, that type of thing that are non-living organisms or components. These slides touch on that a little bit. So when organic systems break down, you know, there's other elements that are in there. So phosphorus, nitrogen, sulfur, and when they break down, they're basically decomposing. So it's like if you have a composter that you use at your house and you put all your waste vegetables and stuff in there, basically what's happening, everything's decomposing, rotting down there. You can smell the smell that's happening there. Okay. So we need to remove the non-dissolved component of those substances, the organic substances. The reason we need to do that is your microorganisms, like if there's a piece of, I'll just use celery as an example. Celery, if celery hit your bioreactor, the microorganisms are not readily going to attack that piece of celery and break it down. They do, however, want suspended solids in a fine makeup that they can attach themselves to or swim around and grab and break those down. Organisms will have nothing to do with organic substance. There's basically nothing for them to live on. And these organisms, biomass, bacteria, whichever term you're comfortable with, they all want to survive. So they need air that we provide and the food from the wastewater. Sand and gravel, for example, inorganics is not something they're going to live on. It needs to be removed. From a process point of view, if it's removed at the front of the plant before it gets to the plant, that's the best, or goes through the plant, that's the best way to go. If it winds up in your plant in large quantities, it will affect valves, pumps. It could build up in corners of tanks and affect process as well. So suspended solids and dissolved solids. That's the best way to explain this. I'll just read this actually. As well as considering whether solids are organic or inorganic, the distinction between the suspended, that is held in wastewater as a distinct actual solid particle or dissolved solids, needs to be made. So suspended solids are basically, if you were looking at something, you could say, okay, yeah, there's particles there, fine particles, and that would be suspended. Dissolved solids are, a good way to think of dissolved solids is if you put some sugar into a cup of water and stirred it up, and now that sugar is dissolved in the water, and those would be dissolved solids. This is just a chart for your information. You know, it's basically you have floatable solids referred to as scum, suspended solids referred to as mixed liquor, and settable solids referred to as sludge. They can be, and all of these can be a combination of inorganic organic solids. Hopefully, most of them are organic, so you can treat them with the treatment process, and that the inorganics have been removed at some point prior to your treatment plan. This is an important slide too. Wastewater solids, 99.9% water and 1.1% solids. So most of what's hitting your treatment plant is water. That's where the flow and loading design characteristics come in. Each of your unit processes is designed to operate a certain flow and load. if that flow and load, or especially flow, is underutilized, you're going to have potentially settling in a plant, or in portions of the plant. If things are settling in there, they're just going to go septic and cause you problems. If you're over the design flow capacity, then it's just going to push things right through the plant, and it will not provide the treatment that's required. So percent of solids, 13% settable, 7% suspended, and 80% dissolved. So based on this slide, you'd be able to get some of the solids out in your primary clarifiers, hopefully. And we'll talk about primary clarifiers in depth in another module, but basically you're allowing the flow to slow down to let some of the solids settle out in the bottom as sludge, and also form scum on top, and both that scum and the sludge are removed. But 80% of those solids are dissolved, and they're flowing right to your bioreactors. Okay, so suspended and dissolved solids, just the makeup in typical wastewater. You'll see that term a lot. Typically, that's, they take an average of when they put documents and information together. It's typically above, you have X number of plants, and this is an average of what they might see. That may or may not be directly related to your facility, but typically in wastewater, they're somewhere around here. And dissolved gases, usually present in small quantities. Dissolved air, mostly those are things that we add at the treatment plant. Okay. Sometimes people don't realize that if you have flow over from one tank to another, or flow over a weir or a gate where the flow is cascading over, it's actually picking up dissolved oxygen, which will impact your treatment process depending on the process that you have. Biological nutrient removal facilities they start off with an anaerobic zone, which flows to an anoxic zone, and we'll cover this all more later as well. But then flows to an aeration zone. If you're adding O2 by a cascading effect of water at the beginning, now that wastewater has additional O2, and it hits your anaerobic zone, which is supposed to have no air, and it will contravene what's trying to happen in that zone. And so much water on the planet, and it follows exactly what we're doing. There's one of the largest misnomers that I hear people talk about is, they'll be hiking in the mountains and they'll see a nice stream that's running. Oh, that's clean water. Well, it may or may not be, because it's all recycled water. There's only so much water on the planet. So important to have an understanding of the water cycle. So we're just going to talk a little bit about the nutrient cycle. So we're not going to go in depth on exactly how to determine the nitrogen phosphorus cycles, but it's important that you have an understanding that there is a cycle there. And basically, nitrogen and phosphorus act like a fertilizer. Same thing you'd put on your lawn. If you go down to a hardware store or something and buy a bag of fertilizer to put on your lawn, it's containing nitrogen and phosphorus. So nitrogen and phosphorus have a cycle as well. And if you do not treat effectively, like we talked about, to go right into your effluent stream. So here's the, I'm just gonna minimize the chat thing here just so I can see my screen. There we go. Okay, so the nitrogen cycle, again, it's good to have an idea or take a look at this, have an understanding. Most of what wastewater operators are concerned about are ammonium to nitrite. Okay. And then it goes into the denitrification cycle. The rest of this is kind of how the whole nitrification system works, but it's important to know it's ammonium to nitrite and then on to denitrification. We will cover nitrification cycles, denitrification cycles, and treatment, as well as phosphorus in later modules. There's a phosphorus cycle. Again, it's good to have kind of an understanding of this. Basically, the way we treat phosphorus or remove phosphorus in wastewater facilities is the BNR facility. You wind up starving organisms at the beginning of your process. Now they want to survive, so they're running around trying to find oxygen, they're trying to find food, and they will actually dump a portion of phosphorus from their cellular membrane. And then as they move through the system, you can kind of think of it as they actually grow a little bit. And as they grow through the system, they wind up uptaking more phosphorus than they released. When you waste from your mixed liquor tanks or your bioreactors to keep your suspended solids where you need to be, then you're getting your phosphorus removal. All right. The next two slides, sulfur cycle, just of interest more than anything, won't be covered. Potassium cycle, same thing. So we did a lot of talking about eutrophication and treatment facilities, and this is a good example of exactly what's happening. If you were unclear, it gives you from your slide, you can take a look at it. It gives you an idea of what's happening in part of that eutrophication cycle. So a lot of information so far this morning. Any questions before I move on? Just give everybody a second.
Sorry, you had mentioned earlier about the smoke test. Did you touch on the dye test as well in the sewer system? I just wanted to hear a discussion on that. The smoke versus dye.
Yeah, no, I didn't touch on dye testing so much. Dye testing for us is mainly used not so much to try and see about infiltration as much as if we're looking for cross connections inside the plant and stuff. You can use a dye test out in the field for sure. You basically put a chunk of dye down a pipe and see which direction it's flowing or basically where it comes out. We do use a lot of it inside the plant if there's problems or concerns about where things may be coming from. Mainly externally is using the smoke testing for sure. And then CCTV work for monitoring the pipes if there's like joint leakage, that type of thing. You can have smoke testing as well that works for finding joint leaks, but the leak has to be a fair size and no water could be flowing inside the pipe when you're doing that testing. And if it's a large enough air leakage or a gap, it could potentially, the smoke can go through that gap and then permeate through the ground.
Hi, me again. So going back to what we were discussing about the bypass, if there's a increasing contaminant midstream or body of water you're discharging in, is there a fail-safe or a mitigation process of removing it?
Not really. And that's the problem. That's why the facilities are there in the first place. Like it's, so if you can imagine whether let's just say it's a lake. Once you've discharged it to the lake, unless it's a floating scum that you could go around and take off easily, there's almost no way to mitigate that. How would you can't turn off everybody's drinking water source. You know, typically they'd all have to go to a boil water advisory until substance cleared. In our lake, like I said, it's a 70-year turnover in that lake. So every drop of water, every contaminant that hits that lake is going to be there for 70 years before it leaves down the road. So yeah, the bypasses, especially in the high rain areas with combined systems, their predication and their assumption is that it's mainly rainwater and it's okay to discharge to the environment. Again, I would prefer to see testing to prevent, or to at least have an idea what's going on. The problem with combined systems is quite frankly, they don't have a choice. The flow or the influent flow into your plant is so large that if you don't bypass a component or a portion of that water, you're just going to flush everything out in your plant. Once you flush your plant out, now you basically have to restart the whole process. Restarting process, you know, maybe you could restart it from one tank to another if you happen to have something, or you'd have to haul organisms in from another facility to seed the plant. And you're talking weeks of no sewage treatment. So you bypass some contaminants. Hopefully it's nothing too toxic. Mother Nature will handle a lot of things and deal with things on her own. But there's no real way to, you know, unless you can isolate that body of water, there's no real way to treat it. You couldn't pump out a lake through a contaminated lake through a treatment facility and pump it back into the lake. I guess if it was a small body of water, you could do something with it, but anything that's larger, whether it be in a running stream or river or creek or a lake bed or an ocean, when it's there, it's there. You know, I'm quite sure we've all seen pictures of like the Exxon Valdez that ran aground and there's oil slicks all over the top of the surface of the water. Although that whole thing was a complete disaster, the fact that it was oil and was floating on top of water is at least something that was manageable, that they could boom off and treat or contain, and then, you know, withdraw off that water. If that would have been something full of dissolved, something that would dissolve in water and mix, you know, how would you potentially treat something like that? Like, there are just no options at that point in time. And sorry, I didn't mean to go on and on there, but I hope I addressed some of your question.
Yeah, I'm covered.
So we only got a few minutes left. I want to start on some primary treatment. Any other questions so far? Okay, I'll just get the slideshow ready to go. Oops. Okay, so preliminary treatment. So we got probably about 10 minutes left here. So we'll just start on this. We'll give us a good head start on the next session. So basically, some way or other, everything winds up in the sewer system, whether it's people dumping things down a manhole, through a business or a facility, through people's homes. Everything winds up in the system. It's important, part of wastewater, the removal of these components is done before it hits your plant. So we're going to talk about screening, a little more in depth about screening, commutation, and grit removal. As we talked about before, screenings, grit removal are awesome. It sounds like your facilities, or the majority of your facilities, have these in place, which is great. Grinding is definitely not a preferred option. Sometimes you don't have a choice. If that's the equipment that you have in place, then you just have to deal with it as best you can. Excuse me. So screening, there's different types of screens: rack screens, bar screens, climbing plate screens, different opening sizes. We have plate screens that have 10 micron opening, so not a lot of things get through there. Next time, our next session, we have a couple of videos from our area and our treatment facilities in Kelowna that I'd like to share with you. Just gives an overall view of a B&R process and what's involved there. So racks, bar screens, commonly spaces are about anywhere from 3/4 of an inch to 6 inches. Where do you think you would find a rack or a bar screen with a 6-inch opening? Because that's pretty big, right? So if you got a trash rack or a bar screen with a 6-inch opening, where are you going to find that? Any ideas? Most of those will be on a
The inlet.
Yeah, usually on a collection system. Collection systems are designed to get everything to a treatment plant. So a lot of times trash racks and whatnot, whether they're mechanically or manually cleaned, they'll be out in the system. And you want to remove tree limbs and any large debris before they're going down, trying to get through a lift station or down the system. So you want to remove them there. Okay. Screens are usually set at 45 to 60 degree angles. So the influent passes through these screens. There's a mechanism that goes up and down and cleans the screens and then dumps into a bin. Okay. So this is a really good example of a manually cleaned trash rack in a collection system. And it's basically the flow is moving this way through this line or through this channel. Any large debris that would plug a pump or jam a pump is hopefully going to get removed from here. And typically you have to clean them manually. Of note, the water level in this channel so there is probably 1/3 of this gate or trash rack that is below the water level. So when they're clean, it's not just a visual inspection. Well, I don't see anything floating on top here. You need to get a rake of some sort out and go down to the bottom of the screen and drag it up. The reason you want to do that is if it's plugging off on the bottom, it's just going to raise the water, is then going to have to get higher to go through the top part. And if it's left, it just gets higher and higher and higher. And there's nothing preventing this flow from, when it exceeds the capacity of this channel, it'll just flow out on the ground. Checking the time here. Okay. So a lot of manual. Hopefully you have automatically clean screens and you're not required to do them manually. Manual screens are definitely cheap and easy to install, but that's only when that component is configured. That's only considering staff or not considering staff time. If you have a manually clean screen, somebody's going to have to go out there and typically isolate it, clean it, put it back in service, and that all takes time. And if people do the calculations over the life cycle, it's usually more cost effective to put some kind of rake mechanism in there and have them cleaned automatically. So this is a good picture of a couple mechanical screens. Usually in these influence screenings, hopefully in most of them, you at least have excuse me, 2 or more screens. If one's taken out of service for maintenance or one's being cleaned or there's something going on, at least you can still use the other one. So it's important to have some redundant equipment there. And just the last thing I want to talk about this morning is disposal of the screenings. The disposal, you know, there's definitely unpleasant material. It's coming down the sewer system that it's just unpleasant. There's nothing much you can do about it. A lot of areas use some kind of sprays and try and clean off the organics and some of the inorganics off those screening material. It's dumped into a bin. Typically, when they're clean, they can then just go to the landfill because they're not considered a biohazard at that point in time. Additionally, when you're cleaning the organics and the inorganics off, it'd be nice if you could just clean the organics off and leave the inorganics because you've taken out the screens already, but it doesn't usually work that way. When you clean the screenings, you remove both organics and inorganics. So following the screenings, it would then go into a grit chamber, or a grit classifier, or a removal system, take out that grit. But it's really important on grit and screenings that they're cleaned and that the organic matter is returned to the waste stream. Your bioreactors, your facility is all designed on flow and load are counting on that food source being available to the microorganisms down the road. So it's important that it's clean for, again, so you can dispose in a landfill so it's not odorous, but it's also a key component of the treatment facility. A lot of information this morning. I'm gonna stop there before I overload everybody anymore this morning. Any other questions following up there? Okay, what treatment of, I'm just reading the question, what treatment of waste from screening should be recommended for landfills? Again, it's just the cleaning or the washing of the screenings is what we typically use and most plants in North America use. When it's been washed, it's considered a non-biological hazard, so it can go directly to a landfill. What's interesting, though, too, that kind of stuff is really good for a landfill because it helps with their decomposition of material as well. Any other questions this morning? I'll just wait a minute, see if anything pops up. Anything pops up? Okay, take some time and review that material that we covered today. There's going to definitely be some questions, and it'll be as interactive as possible. And I'm going to be waiting for people to chime in with some answers before as we start the next session. Each session moving forward is going to be a little bit like that, so there will be definitely a heavy time spent on review. That review is going to target things that I feel are important for operations, as well as things that are important part of an exam prep, getting ready to write your exams. I can't stress enough that, and you'll probably hear me repeat it several times, that we're not teaching to the exam, but we're definitely going to cover things that are very, very similar or on the exam. And I'm going to leave it at that this morning. I don't see any more questions. I'd like to thank everybody for chiming in, and whether it's speaking on the mics or typing in some of the answers, it's great to have some more interaction this morning, and I really appreciate it. Thank you.
Right, thank you again, Mike. And that brings us to the end of session number 2, wastewater tutorials. Have a good day, everybody.
Have a good day.
Okay.
Okay, take care. We'll see you next week.
See you next week. Keep safe and well. Bye bye.
You too.